So now here's a circuit I put together where we have a 555 timer and a light dependent resistor. If I get it dark enough, the output goes high. And when the output goes high, the red LED lights up. So now here's the diagram I put together for the 555 timer where when the LED gets dark enough, then the output goes high. The red LED lights up. I also got the pin numbers there, which are for all dual inline package integrated circuits, and the names of the pins for the 555 timer. The actual NE, or the actual 555 timer that I use is the NE 555 timer. I may have micro A 555 timer somewhere, but in any case, if you can work with the NE 555, it'll probably work the same for the micro A 555. So now, as always, with the 555 timer, you need to power it. So you got positive supply to pin number 8, we're using 5 volts there, and the negative supply to pin number 1 over there. The way that I do that on a breadboard, I got a jumper to the positive rail there. The positive is actually coming from the alligator clip up there, but it makes its way over to here. And then for pin number 1 to the negative supply with the jumper that heads back over that way, right there. Of course, this particular circuit, as we mentioned before, the LED turns on, the output goes high when it gets dark enough on the light dependent resistor. So now pin 2 is the trigger pin for the 555 timer. The way we have this wired up, I'm actually making a direct connection to the negative supply, but whatever. We have less than 1/3 of the supply voltage. That's all that matters. It's telling the output to be high, although the output is not high. Unless it's dark enough, because pin 4 overpowers that. So we'll take a closer look at pin 2 over here. There you can see it's directly to the negative supply right there, giving a low input. But again, it's not as powerful as pin 4, so once we get it dark enough, now the output goes high, the red LED lights up. So that covers pin number 2. So now we come back to the schematic. We got pin number 4. It overpowers pin number 2. Pin number 2 tells the output to stay high all the time. But pin number 4, when it's bright enough, it gets a low input. You can see we got the light dependent resistor right there, and that tells the output to go low. Pin number 4, the reset pin, is more powerful than pin number 2. So the output stays low. We can adjust the sensitivity with the 100K resistor right there, but 100K works pretty well in this instance. So there you can see 100K to the positive supply right there. We're sharing a row there, that's plenty fine. And our light dependent resistor here going to the negative supply. So now there's enough light falling on it so that it's holding the output low. The red LED is wired to light up when the output is high. When I cover this or turn the lamp off, I can do both, then the output goes high and the LED lights up. So now, we saw the way this 555 timer here is wired up. We get it dark enough on pin 4, it stops holding the output low, and it lets pin 2 pull the output high, which pin always wants to do. And that's what it's doing. It's making a connection. There's some transistors though, so it's not a perfect connection. You lose at least a volt. But in any case, it makes a connection from the positive supply through the integrated circuit right there. And the red LED lights up because it's going to the negative supply. Not because it's a red LED, just because I usually wire the red LED. So it lights up when outputs are high. I find that to be a helpful indicator. So yeah, there's pin 3 going to 220 ohm resistor because we do have 5 volts, although not all of it's making it. Long lead the anode of the LED up to the resistor, short lead the cathode to this jumper that goes to the negative supply. Doesn't matter that it's connected to 10-1, we could go to the negative supply anywhere, but this helps to keep things compact.